Hey guys, in this video I'm going to show you how I built a walk-in chair, taking you through 4 months of work that led to this moment. I was asked to build a walk-in chair for an art project with a budget of 200 euros. The chair had some specific requirements. It had to walk on only 4 legs, with no visible mechanism, and its movement needed to mimic a natural walk-in pattern. It also had to be ready before June 21st, the date of the final presentation at my friend's art school. I started studying the walking patterns of quadruped animals like elephants and horses. Their opposite legs move in sync, but I couldn't afford to lift the legs off the ground for stability reasons. Then I thought about cross-country skiing and combined these two movements to create a motion where the chair's feet always stay on the ground for stability. I used freewheels, like those in bicycles, which turn in one direction but not the other. This ensured the chair would go forward. This first simulation helped me nail down the exact dimensions needed for the desired step size. Once I had a clear idea of the leg's motion, I began designing the mechanism. I needed one power source to drive all 4 legs in sync, and I immediately thought of an internal combustion engine camshaft, which controls multiple valves with precise timing from a single rotation. This part that I called the crankshaft became the heart of my design. I assembled the crankshaft with the frame and simple pivots for the legs. The plan was to power the crankshaft's rotation to make the whole chair move, as seen in this simulation. To do this, I added an electric motor and a chain to drive the gear. I needed a motor that provided high torque at a low speed, and I found it exactly where you would expect it, Lidl. This small screwdriver provides 10 Nm of torque at 200 rpm. To achieve the desired speed, the crankshaft needed to turn at about 40 rpm, so I needed a reduction ratio of 5:1. This also boosted the torque which was necessary to support the chair's weight. I got a huge 50-tooth gear and a 10-tooth gear thanks to Romain from Vélo Passion 58, who provided me with used bicycle parts from his workshop. Building the frame was straightforward. It just involved bending steel sheets and welding them together. The crankshaft was composed of 3 separate axles, and I realized I had overlooked a crucial factor: alignment. In CATIA, aligning axes is a one-click process, but in real life, misalignment and excess play can block the mechanism. To fix this, I added 2 guides bolted to the frame, forcing the central axle into alignment. Then I took the risk of welding the crankshaft components together, deleting the excess plate. Despite my mediocre welding skills, I managed to make it work. The motor only had an on-off switch, with no speed control, so I bought a 4V controller and did some wiring and soldering, allowing me to control the chair's speed with a small scroll wheel. Then, I mounted the chair, installed the freewheels and adjusted the chain alignment. It made its first steps with difficulty, but after some fine-tuning, the mechanism worked perfectly. After the chair left the workshop, by itself, I sent it to Dijon, where my friend worked on its visual aspect. On the day of the presentation, I went there to provide technical support. I was incredibly stressed and imagined all sorts of failure scenarios, but at the crucial moment, it worked exactly as intended. This project taught me valuable lessons. First, the importance of production resources. It's crucial to evaluate the necessary tolerances for each part and what level of precision you can achieve with the tools you have. I also learned about the time-cost-quality triangle in project management. At some point, I had to sacrifice quality to respect the deadline, while still meeting the specifications. Finally, I learned how to work under pressure. Despite dealing with exams, assignments, and setbacks, the experience was 100% worth it. I had great fun cutting, drilling, soldering, and even welding. Though my focus is more energy engineering, I must admit that this project rekindled my interest in mechanical design. I'd like to thank everyone who helped me with this project, especially Romain from Vélo Passion 58 for providing parts and assistance, the technicians André and Alain for their help with machining, my teachers Steve Bossard and Anthony Perriot for their timely advice, and the ISAT Formula student team for kindly lending me tools when needed. Thank you guys.